Okay, away we go. When you're done, hand in both the packets that we did last week. You should have plenty of time to get those done. I am recording up here, so again, I'm not calling people by name. You get some, I'm not going to say your name. Okay, we're dealing with absolute value today. Absolute value. Now, some of you had me for Algebra 1. This is going to look really familiar. I'm just warning you that there's a couple problems at the end we did not do last year. Now, these first ones, you're evaluating the answer. So, absolute value, it says right up there, you don't need to write it down. It's distance from 0 on a number line. So, the absolute value of -5, okay? So, I say, okay, how many units is it from -5 to 0? Now, when you're counting units, you're counting by positives. You're just counting naturally. So, 1, 2, 3, 4, 5. So, it's at 5, okay? Next one, absolute value of 4. How far is it from 4 to 0? 4. You always label it as 4. Now, what we have now is the absolute value of -2 minus 7, and then that absolute value is closed, minus the absolute value of -13 plus 3, and then that absolute value. Now, that subtraction sign between the absolute value, you carry that down. You carry that straight down. Now, you need to find out what your absolute values actually are. So we have to perform the operation within the absolute value. -2 minus 7 is -9. And then -13 plus 3 is -10. So what's the absolute value of -9? How far is it from -9 to 0? 9. So 9 goes in front of the subtraction. And then what's the absolute value of -10? 10. Now, 9 minus 10 at the end is -1. Now, you can get a negative answer for the final answer, okay? Certainly works out that way. But within the absolute values, those come out as positives. Okay, next one. We drop down the addition between the absolute values. -4 plus 10 is 6. And then here we just have -12. So the absolute value of 6 is 6. The absolute value of -12 is +12. You're fine. 6 plus 12 is 18, okay? So, that's what we have. Okay, turn to page 2. Now, what we're going to be doing most of this is solving absolute value equations. You're going to have some problems on that, like I did on that first page, where you have to just evaluate expressions. Now you're solving for a variable. I have a certain way I set this up that's pretty foolproof, okay? I'm not going to do all these examples here today because I want to give you guys time to work on your assignment. It says the absolute value of x equals 10. When I have to solve an absolute value equation, I'm looking for 2 answers, and here's why, okay? First off, what I like to do is replace the absolute value, and it might seem kind of pointless on this particular problem, but it's going to help us as we move around. And I'm going to replace the absolute value with a certain variable. It's called d. D stands for distance. D equals 10. So just remove the absolute value and replace it with D equals 10. Then I like to make kind of a 2-sided table with 2 equals on each side. Now here's why there's 2 answers. Where is it possible to be 10 places from 0? There's 2 places on a number line you can have a distance of 10 from 0. 10. I would put 10 first and then -10. So that could equal 10. It could equal -10. Now this is a pretty easy problem because within the absolute value we just have the x variable. So x and x. So we essentially have it solved. X could equal 10 or it could equal -10. Okay, next problem. We have the absolute value of x plus 12 equals 2. Okay? So equals, and I will replace my absolute value with d. D equals 2. So to have a distance of 2, you could be at +2. And you could be at -2. Now, within the absolute value, we have the expression x plus 12. So on the other side, I don't just write x, I write x plus 12. Okay? And now I solve each equation. Okay, so I do the opposite of plus 12, which is -12 from both sides. So I subtract 12 from 2, and x could have a value of -10. Okay? Which makes sense because if I put -2 in for x, -10 in for x, and add 12, that's 2, and the absolute value of 2 is 2. Now on the other side, there's another possible value to take me to an absolute value of 2. I would subtract 12 from both sides, I get -14. See, that works too because if I replace x with -14, -14 plus 12 is -2, but the absolute value of -2 is +2. Okay? So And I'll do two more, okay, on this page. Okay, the absolute value of f minus 6 equals 4. So that means we have a distance that's equal to 4. So that means the inside expression could equal 4 or it could equal negative 4. All right, now I bring in f minus 6 and solve each equation separately, okay? So add 6, 4 plus 6 is 10, which makes sense because or f equals 10. Because if I replace the variable f with 10 and subtract 6, that's 4. Well, the absolute value of 4 is 4. Then on the other side, if I add 6 to both sides, same thing. Negative 4 plus 6 is 2. Now, if you take 2 minus 6, yes, you get negative 4, but then that results in an absolute value of 4. Okay? And then the last one I'm going to do, the absolute value of 3 on this page, the absolute value of 3x equals 12. So, d could equal 12. Okay? Now that, again, distance of 12, that could be 12 or negative 12. I use d because that stands for distance, okay? To be 12 units from 0, you could be at 12 or negative 12. And then I put 3x. And then I just divide each side by 3. So 12 divided by 3 is 4. Makes sense because 3 times 4 is 12. Absolute value, 12 is 12. On the other side, I divide by 3, and that's negative 4, okay? 3 times negative 4 is negative 12, but that results in an absolute value of 12. Okay? Any questions up to this point? Okay. Now, I'm going to do this page, and here we got some things we need to figure out before I go to my table. Okay? I'm going to replace the absolute value with d, and I have minus 2 equals 4. Now, we don't know what d is. Is this the next problem? Negative 3x minus, okay. So you still replace that with d, but now, what would we do at the minus 2 to find out what the heck d is here? You just add 2, okay? You know what I'm saying? You have to solve the equation for d. See, on this first page, the equation was already solved for d, but now it's not. So to find what your distance is, you have to add 2 to both sides, and d equals 6. So the two places I can be 6 from 0 is positive 6 and negative 6. And then I use the expression negative 3x to solve for the variable, okay? So then I divide by negative 3 on both sides. So 6 divided by negative 3 is negative 2. Divide by negative 3 on both sides. Negative 6 divided by negative 3 is positive 2. So that's why I use d, so then, you know, it's simple. It makes a simpler equation where I can visualize what's going on and what I need to do. Okay, next one, we have 5. Here's what I don't want to see. Don't write this. I do not want to see distribution going on. You do not do that into an absolute value, okay? It is not like a parentheses. If you do that, you will get the answer flat wrong, okay? You won't get a single point for that. Okay, so I'm still replacing that with d, but it's 5d equals 35. Now I need to solve for d. I'm going to need to divide both sides by 5 now because that 5d means 5 times d, okay? So I divide both sides by 5, and 35 divided by 5 is 7. So a distance of 7, that could be a positive 7 or negative 7, either one, okay? And then I bring back the expression 2x plus 4 on both sides of the thing. Okay, so to solve, I need to subtract 4 and then divide by 2. So if I subtract 4, that's going to be 3, so 2x equals 3. Divide by 2, and x is 1.5, or 1 1/2, okay? Now the reason that works is because 2 times 1.5 is 3, plus 4 is 7. The absolute value is 7. Then when you multiply by 5, you get 35, okay? Now on the other side of things, we subtract 4 from the negative 7, that's negative 11, and then divide by 2, and that's negative 5.5, okay, or negative 5.5. All right, I'm going to do 2 more on this page, and we will cross out the next page, okay? Next problem, we have 6 times the absolute value of 5x minus 2, and then after the absolute value, we have minus 3 equals 21. See, do not distribute. You do not apply the distributive property here. Just remove your absolute value, replace it with a d variable. Now your d is going to be multiplied by 6, and it's going to have a 3 subtracted, and it's going to equal 21. So obviously I need to solve for my distance, my absolute value, by adding 3 and then dividing that result by 6. So I plus 3, that's 24. Then I divide by 6 on each side, and d equals 4. So to have a distance of 4, you can be at 4 or negative 4. Now you bring back the absolute value of 5x minus 2, okay, of the expression within to solve for the actual variable, okay? So we add 2 and divide by 5. If I get decimals, that's okay. 5 times x equals 6, divide by 5, and x is 1.2. Remember, if you get a really crappy looking decimal, you're going to need to round that, okay? The decimal has to be finite, okay? Now right here, I add 2 and divide by 5. So negative 4 plus 2 is negative 2. Then I divide by 5, and we get negative 0.4. Okay, either one of those are okay. Okay, next one's kind of a trick one. It's not long, but I'm going to keep going. Okay, I'm going to do this one because this will come up on the assignment. Replace your absolute value with d. You're going to have a negative 4 in front as a multiplication operation equals 16. Then divide by negative 4 on both sides, and d equals negative 4. I have a question. When you're measuring distance, do you ever measure by negative? If Mr. Snow's in shop class tells you to measure something, do you ever count by negatives? No. If d is equal to a negative number, you do not proceed into the table. It is no solution. Did everybody hear that? If d is equal to a negative number, it's no solution. Okay, cross out all the problems on the next page because that's just the same stuff. Okay. Now, those of you who had me last year, we did that, okay? We did not do these, okay? So nobody knows how to do these yet, these next ones, okay? These are 2 at the end. I'm going to do a couple, and then I'm going to turn loose on your assignment, okay? Solve the absolute value equation, check for extraneous solutions. Now, replace your absolute value with d, please. I'm going to do 3 at these 3, and I'll cross out the 2 on the back and put equals 4x minus 1, okay? Now, do we really know what the d value is on this one? No, you don't. Here's what you need to write then. And the reason you don't, because we don't know what x is, okay? I mean, on the other problems it said d equals 8, d equals 3, d equals negative 4, which was a no solution, okay? We don't know what d is equal to. So what you're going to do is you're going to proceed to your table, but I want you to write yourself a note here, please, and that is check answer at the end. Check answer as at the end. I'll explain what that means, but every time we really don't know what d is equal to, we need to check our answers at the end, and I'll explain why you have to check at the end here in a bit. Okay, you didn't have to on those other ones. If you know that d is equal to that positive, you go right there and solve it, okay? Now, you put equals. On one side, you put the expression 4x minus 1 behind the equals, okay? Makes sense? On the other side, you need to switch both of your terms to their opposite values. So the 4x is positive here. Well, now it's going to be a negative over here. And the 1 that's negative on the first side is going to be a positive on the second side. So you just switch the values of both the terms in the expression. Okay, I want to go kind of slow through this part here. Okay, with me so far. Now, bring in your 2x minus 3. You write 2x minus 3 on this side, and you don't switch the 2x minus 3. You leave that the same. Okay, it's what your d is equal to that needs to be switched. Now you solve both the equations, and you're going to check your answers, which I'll explain here in a minute. So 2x and 4x. Give me one of the x's you want to get rid of. I don't care. You can search 2 minus 2x minus 2x from the 4x. So negative 3 equals 2x minus 1. So we're operating on the right side if we do it that way. Then we add 1, which is negative 2. and then 2x, then divide by 2, negative 1 equals x. Now I will check that answer after I get the other side solved, okay? Okay, what would you like to do on the other side? You want to subtract 2x or add 4x? Doesn't matter. Add 4x. So it's going to be 6x minus 3 equals 1, okay? Then you add 3, and that takes you to 4. 6 times x equals 4. So you're going to have to divide 4 by 6. Now that's a crappy looking decimal when you divide 4 by 6. Remember, you leave that on your screen, and you hit second PRB equals, okay? So 4 divided by 6 is 0.6, it goes on, then you click the second key, PRB equals, and that's 2/3. Now, here's how you check your answer. On the D equals 4x minus 1, put a parentheses around your x, and up above it put negative 1, and down below it put 2/3, okay? If either answer is negative, then it's not a solution. If it's positive, it is a solution, okay? So what's 4 times negative 1 and then minus 1 going to give me? What's 4 times negative 1 and then subtract 1 going to give me? Somebody call it out. Negative 5, that's a negative, isn't it? Well, if it's negative, when you plug it in, you need to cross that answer out. That's not a solution because the D cannot equal a negative number, okay? Now, go on your calculator, and now take 4 times 2/3, okay, minus 1. 4 times 2ABC3 minus 1. What is it? Just tell me what it comes out to be.
1 and 2/3.
That's positive, isn't it?
Yep.
So you circle that. That's an answer. So when you plug it in, it has to result in a positive. If it results in a negative, you cross it out because the distance can't equal a negative. Okay, next one. Okay, so D equals 5x plus 2. So again, I don't know whether D is equal to a positive or a negative, so all I can do at that point is just go to my table, and on one side we put 5x plus 2. On the other side, we make it negative 5x minus 2, okay? Switch both the terms to their opposite sign. Then you bring back in the expression 3x plus 5. Now don't reverse anything about the 3x plus 5. Okay, it's what the D is equal to. Now you find both of your answers. Okay, I'll subtract 3x. Doesn't really matter, you can subtract 3x or 5x. So 5 is equal to 2x plus 2. Then you're operating on the right side, you subtract 2 from both sides, and that's 3. 3 is equal to 2x. Then you divide each side by 2, and 1.5 is equal to x, okay? We will need to check this later, okay? Because when you don't know what your D is equal to, you need to make sure the answers give you a positive, okay? Then plus 5x to 3x, and that's 8x plus 5 equals negative 2. Then you subtract 5 from both sides, and 8x equals negative 7. Then you divide both sides by 8, and it's negative 0.875. That's kind of a long decimal. I'm just going to write negative 7/8. If it's more than 2 decimal places, just second PRB it. Now, we got to check to make sure those answers give me an actual positive. So I put a times next to my x, and then a parentheses. I put 1.5 above it, negative 7/8 below it. Quickly on your calculator, multiply 5 by 1.5 and then add 2. Tell me what that, actually, I don't even need to know the answer. You tell me if that's a positive or a negative.
Positive.
Okay, so that answer is a viable solution. You circle it. Now, go to your calculator, take 5 times negative 7/8, negative 7 ABC 8, and then add 2. You tell me if that's positive or negative. It's negative. It needs to leave then, because a distance cannot equal a negative, right? All right, I'm going to do one more, okay? This one's kind of not a hard one, but it's a little bit different. Always replace the absolute value of D. So you're going to have 7D equals 21x minus 49. Now, what do we have to do about the 7 that's multiplied by D? You're going to divide. Here's how you divide this now. You're going to divide by 7 to get rid of the times 7, but then you divide the 21x by 7 and the 49 by 7 separately, okay? I'm going to walk pace here a bit as you process that, okay? So, you will need to divide both your x term and your constant term by 7 separately, okay? So then that's going to make 3x minus 7, okay? And I don't know what d equals, I still don't, okay? But at least I have d by itself, it's solved for, so then I proceed with the same steps, okay? On one side, 3x minus 7, the other side is negative 3x plus 7. You've got to reverse both the signs. Then you bring back the expression 8 minus 3x. And then you proceed to solve the problem. So we have a negative 3x, positive 3x. I'll add the 3x to both sides, and that's 6x. 6x minus 7. Then I will add 7 and divide by 6. So add 7. That's going to be 15 equals 6x. Divide by 6, divide by 6. And 2.5 is equal to x. Now, the other side. Aren't they exactly the same? X term. Then you get rid of them. Is 8 equal to 7?
No.
Good, then you cross out that side. Now you still have to check your answer, 2.5. Make a times dot and put 2.5. Somebody 3 times 2.5 minus 7. What's that give me, a positive or a negative?
Positive.
Okay, then that's an answer, okay? Now don't worry about the other side because I ended up with no solution. Cross out the ones on the next page and go ahead and work. You don't have to, again, if you don't know what your D equals, you have to solve the problem and plug it back in, okay? What you're doing here is just evaluate. So, absent by negative 5 is how far flying with negative 5 is from 0, that's 5. 4. Okay. Here you drop the outside operation.